Hi, welcome to my channel. This video I'm going to explain about linear independence of vectors and linear dependence of vectors. So before beginning this video, let us see what is the definition for linear independence and linear independence, and I have given some examples for this. So the first one is linear independence. Let us check the definition. Let V of f be a vector space, that is V of f is going to be a vector space. A finite set, let us take a finite set alpha 1, alpha 2 up to alpha n of vectors of V is said to be linearly independent if a1 alpha 1 plus a2 alpha 2 etc. up to an alpha n equal to 0 implies a1 is equal to a2 is equal to etc. an must be equal to 0. That means if we take a vector space V of f and a finite set, and if you are going for a equation like this with a given vectors alpha 1, alpha 2, etc. alpha n, then all of them when you take the equation should be equal to 0. That implies a1 is equal to a2, etc. a is equal to 0. That means it has all of them must be equal to 0. They are not depending on each other. Each one must be equal to 0. So in that case we say that the given vectors are going to be linear independence. So for example, prove that the set S is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1 is linearly independent in V3R. So V3R, so 3 set of vectors, and we know that it's going to be a finite set. So according to the definition, we'll go for the equation a1 alpha 1 plus a2 alpha 2 etc. an alpha n is equal to 0. So here 3 vectors. So we'll be getting a1 into 1, 0, 0 plus a2 into 0, 1, 0 plus a3 into 0, 0, 1, which is equal to the vector 0, 0, 0. That is 0 stands here for 0 vector. So our usual component wise addition, we'll be getting a1, a2 multiplication, a1, 0, 0, 0, a2, 0, 0, 0, a3 is equal to 0, 0, etc. And then when you add, you'll get a1, 0, 0, you'll get a1, a2, a3 plus 0, 0. So that is going to be a1 plus 0 is a1. Similarly, a2 plus 0 is a2 and a3 plus 0 is equal to a3. So we'll get a1, a2, a3 which is equal to 0, 0, 0. That implies a1 equal to 0, a2 is equal to 0, a3 is equal to 0. Hence, according to the definition, the given set of vectors are going to be linearly independent. That is, each one has a trivial solution. a1 is 0, a2 is equal to 0, etc. a3 is equal to 0. So they are not depending on each other. Each one is going to be equal to 0. Then we say that the given set is going to be linearly independent in V3R. Now we'll see what is the definition for linear dependence, and I am going to explain an example also for that. So linear dependence in the sense, let V of f be a vector space. A finite set alpha 1, alpha 2, etc. alpha n of vectors of V are said to be linearly dependent if there exist scalars a1, a2, etc. an in f. Not all of them are 0, that is, some of them could be 0, but not everything is equal to 0, such that a1 alpha 1 plus a2 alpha 2 plus a3 alpha 3 etc. up to an alpha n is equal to 0. So the definition says that if this equation is equal to 0, that is the 0 vector, then this a1, a2 etc. an, any one could be 0, but not all of them must not be 0. Then in that case it is going to be linearly dependent. That means one vector is going to be depending on the other one. So in that case it is going to be a linear dependence. So let us see the example. Prove that the set of vectors S1, 0, 0, 2, 0, 0, 0, 0, 1 are linearly dependent in V3R. So we'll go with the equation a1 alpha 1 plus a2 alpha 2 plus a3 alpha 3. Here your alpha 1 is 1, 0, 0 and alpha 2 is 2, 0, 0 and alpha 3 is going to be 0, 0, 1. So substituting that, just multiply is a component wise multiplication and addition. So I hope you know that. So a1 0 0 2a2 0 0 0 0 a3 equal to 0 0. So here when you add a1 plus 2a2 and the 0 0 0 component wise addition and 0 plus 0 plus a3, so we'll be getting a1 plus 2 a2 0 a3 is equal to 0 0 etc. So from this we'll get that a1 plus 2 a2 equal to 0, and this is of course we don't have anything, 0 value, so a3 is equal to 0. That means a1 is equal to minus 2 a2 and a3 is equal to 0. Anyone could be 0. That's according to the definition. Not necessarily, but it could be 0. So here a1 is equal to minus 2a2 means an is equal to minus 2k. That is, k is going to be any arbitrary value. That means if you want to know the value of a1, then we need to know what is a2 because they are depending on each other. So here not all the scalars are 0 in this case. Hence the given set of vectors are linearly dependent in V3R. So the way to define or to find whether the given set of vectors are linear dependence or independent. In linear independence, you will get all the scalars to be 0. In linear dependence, any one of the vectors will be depending on the other vector. Hence why it is linear dependence. Thanks for watching. See you in the next video.